Hello students, my name is Om Prakash Dubey and I am faculty of chemistry. In this session I am going to discuss mole in terms of volume, that is what is the relation between mole and the volume of a gaseous chemical substance, and mole in terms of volume. Mole in terms of volume, that means how will you calculate the volume of a given gaseous chemical substance if the number of moles or the mass of a number of particles of a chemical substance is given. To calculate the volume of a gaseous chemical substance, we generally used the ideal gas equation, which is PV is equal to nRT. In this equation, this is ideal gas equation. This equation, P is the pressure of gas, V is the volume of gas, and N is the number of moles of gas, and T is the temperature in Kelvin, and R is gas constant, and the value of this gas constant is R is 0.0821 liter atmosphere per Kelvin per mole. If we have to calculate the volume of a gaseous chemical substance, like suppose calculate the volume of 1 mole of CO2 or any gas at NTP condition. NTP condition, that is normal temperature and pressure, and the normal temperature is 0 degree C or 273 Kelvin or 273.15 Kelvin exactly, and the normal pressure is 1 atmosphere. This is equal to 760 mm, which is equal to 760 torr. If we have to calculate the volume of 1 mole of gas at NTP condition, and from the ideal gas equation, PV is equal to nRT, and V, the volume of a gaseous chemical substance, is nRT upon P. The number of moles of the CO2 is given, which is 1 mole, and the value of R is 0.0821, and the temperature and its normal temperature is 273, approx 273, upon the pressure is 1 atmosphere, and by calculating all this we get 22.4 liter. That means the volume of 1 mole of any gaseous chemical substance is 22.4 liter, that is 22,400 milliliter or 22,400 cubic centimeter for 1 mole of any gaseous chemical substance. Like here, CO2 is given, if NH3 is given, if oxygen is given, if ozone is given, then always the volume of 1 mole of any gaseous chemical substance at NTP condition is 22.4 liter or 22,400 ml. If the number of moles increases or decreases, then obviously the volume of a gaseous chemical substance increases or decreases, because the equation is PV is equal to nRT, and R is the gas constant. Suppose at constant temperature and at constant pressure, like if we write at constant temperature and at constant pressure, suppose if the given condition is at NTP condition, then we can write the V is directly proportional to the N. The volume of a gaseous chemical substance is directly proportional to the number of moles of a gaseous chemical substance which is taken in a container. If the number of moles of a gaseous chemical substance increases, the volume of a gaseous chemical substance also increases. If the volume of 1 mole of a gaseous chemical substance at NTP is 22.4 liter, then volume of 2 mole of gaseous chemical substance is 2 multiplied 22.4 liter, which is 44.8 liter. That means simple V is directly proportional to N, or we can write V1 upon V2 is equal to N1 upon N2. That means if the temperature and pressure is constant, then we can write V is directly proportional to N, and if the condition is given, which is NTP, then volume is 22.4 liter for the 1 mole of gaseous chemical substance. Like, take an example of volume. Like suppose calculate the volume of 1.5 multiplied 10 raised to the power 23 molecules of ammonia at NTP, and we can easily calculate the number of moles of ammonia at this condition and the number of moles of ammonia, which is equal to the given number of molecules 1.5 multiplied 10 upon 23 upon the fixed value, which is Avogadro number 6.02 multiplied 10 upon 23. It comes the number of moles, and if we have find out the volume of ammonia, then number of moles multiply 22.4, because the condition is given, which is NTP, then 1.5 multiplied 10 upon 23 upon 6.02 multiplied 10 upon 23 multiplied 22.4, which is equal to 5.6 liter. That means 1.5 multiplied 10 upon 23 molecules of ammonia, it contains 5.6 liter of ammonia. Simple. Mole in terms of number, mole in terms of mass, and mole in terms of volume. These all three are related as, like, this is the mole, and is the number of particle, number of atom, number of molecules, number of ions, and this is the mass of chemical substance, and this is the volume at NTP in liters. These all are related with the number of moles. If the number of moles is given, we can calculate the number of particle by multiplying the Avogadro number. Like 1 mole of any chemical substance is equal to the n naught particles, and if the number of particle is given, we can easily calculate the number of moles dividing by the n naught Avogadro number. If the number of moles is given, we can calculate the mass of a gaseous chemical substance or mass of a chemical substance by multiplying with molar mass, and if the mass of a chemical substance is given, we can calculate the number of moles dividing by the molar mass, and if the number of moles is given, we can calculate the volume of the gaseous chemical substance multiplying with 22.4, or if the volume of a gaseous chemical substance is given, we can calculate the number of moles by dividing it 22.4, and we can easily convert number into mass, or number into volume, or mass into number, or mass into volume via the number of moles. Like suppose calculate the number of moles, number of molecules, and the volume of oxygen in 16 gram of O2. Calculate the number of moles, number of molecules and the volume of 16 gram of oxygen. That means the mass of the oxygen is given. First we have to calculate the number of moles, and by calculating the number of moles we can easily calculate the number of molecules, we can easily calculate the number of atoms of oxygen, and we can calculate the volume. The mass is given, which is 16 gram. First this mass is divided by the molar mass, we get the number of moles. That means the number of moles of oxygen is 16 and the molar mass of this oxygen is 32, which is 1 by 2 mole. And by calculating the number of moles of oxygen we can calculate the number of molecules of oxygen is 1 by 2 multiply the Avogadro number, that is 6.02 multiplied 10 power 23, which is 3.01 multiplied 10 power 23 molecules. And we can also calculate the volume of oxygen at NTP. The volume of oxygen at NTP is given number of moles, which is multiplied by the 22.4, and the moles is given 1 by 2 multiply the 22.4. The volume of 16 gram of oxygen at NTP is 11.2 liters. So by this equation, by this relation, we can easily find out the relation between the number, moles, mass and the volume of a gaseous chemical substance or any chemical substance. Thank you.